So now we are going to study the topic on 4-stroke petrol engine. So first you should know how to write a sketch. Okay, so that is very important. A schematic sketch is very important, and we can write it very easily. I am going to show you how to do it. So first we have to draw 3 parallel lines, a reference line. So these are the just a reference lines. Okay, so these are 3 reference lines. And we are going to start with the cylinders. So while writing the parts of IC engine, we have written the cylinder, right? Same type of cylinder, we have to write 4 cylinders we have to write. Why I have drawn the 3 reference lines? Because all the cylinders, all the 4 cylinders I am going to represent, that should be of same size and shape. So that's why I written the 3 reference lines, so that all will be similar. Okay. So this is the, what is this? Cylinder number 1. All are of same cylinder only. Another cylinder. This is another one. And this is the what is this? This is the cylinder. So next, what is this? What is this? What's going on? Crankcase. See, if we draw 3 parallel lines, we are going to get similar cylinders. Okay. So as I told, the name itself indicates 4-stroke petrol engine. So to complete one cycle, the piston has to reciprocate 4 times. The piston has to reciprocate 4 times. Hence it is called as what? 4-stroke. And what is the type of fuel we are going to use? Petrol. So that's why it is the 4-stroke petrol engine. What is the first stroke? The first stroke is the suction stroke. What is the first stroke? Suction stroke. Second one is compression stroke. Okay, compression stroke. The third one is power stroke. Okay, the third one is power stroke. And the fourth one is exhaust stroke. Okay, so to complete one cycle, the piston has to reciprocate 4 times. Okay, so that's why it is called as 4-stroke. The first stroke is the suction stroke, compression stroke, power stroke, and exhaust stroke. Is it clear? Now, so we have to represent label the parts for the first stage. Okay. So what is this? Piston. So what is this? Crank case. And we will be having a piston. So this is the piston. So this one is not piston, it's a cylinder. Next we have a, what is this? Connecting rod. And what is this? Crank. Okay. At the center, what will be having? Crank shaft. Is it right? And what is the upper portion is called as? Cylinder. So these are the various parts. You have to label it for the first stage. That much is okay. So now please pay attention, don't write. Okay. Now, so what is the first stroke? Suction stroke. Now I am going to explain you what are the explanation that you will write for the first suction stroke. So during the suction stroke, the piston will be at the top dead center. The piston will be at the top dead center. Inlet valve will be open. Exhaust valve will be closed. Okay. So during the section stroke, the piston will be at the top dead center. inlet valve will be open and the exhaust valve will be closed. Is it clear? Now the piston is going to move from top dead center to bottom dead center. The piston is going to try to move from top dead center to bottom dead center. So there will be vacuum will be created inside the piston. So due to the movement of the piston downwards, the vacuum will be created inside the cylinder. So due to this, the fresh air fuel mixture, so that is also called as charge. Fresh charge is a combination of air plus fuel. Enters the cylinder. So this is what the suction stroke. So this can be represented in PV diagram. So this is a pressure and volume. PV, pressure, volume, not velocity. It is a pressure and volume diagram. See what happened? The piston is moving downwards. The volume of the cylinder is increasing or decreasing? Increasing. The pressure remains same. The volume of the cylinder is going to increase. So this is a to B. A to B represents the suction stroke in pressure and velocity, pressure and volume diagram. Is it clear? I'll repeat once again suction stroke. During the suction stroke, the piston will be at the top dead center. What is the position of inlet valve and exhaust valve? Inlet valve will be open. This is the exhaust valve will be closed. This is the inlet valve and this is the exhaust valve. At the middle you have to write the spark plug. Spark plug. Is it clear? So inlet valve will be open, exhaust valve will be closed. The piston is going to move from top dead center to bottom dead center. During that, the section will be created in the cylinder. The fresh air fuel mixture enters the cylinder. During this cycle, the crank will be rotated by 180 degree. Yesterday I will say 180 degree. Suppose this is a 0 degree. This is the starting of the suction stroke. At the end, so it will be completed 180 degree. So that completes what? Suction stroke. The same can be represented in pressure and volume diagram. This A to B. Is it clear? Okay. So now the piston is at where? Bottom dead center. Right? So the crank has to be rotated by how many degrees? See the difference from this to this. So there must be a difference of 180 degree. See, suppose this is a 0 degree. So have given a rotation like this. So this is a distance of how much? 180 degree approximately. So now which stroke we are in? We are in compression stroke. So during the compression stroke, both inlet valve and exhaust valve will be closed. So now the piston is going to move from bottom dead center to top dead center. Okay. So this is one stroke is over. So the piston has came from top dead center to bottom dead center. So now we are at the compression stroke. Now the piston is at the bottom dead center. Now the piston is going to move from bottom dead center to top dead center. What happens? So during the movement, the air fuel mixture present in the cylinder, it will be compressed to high pressure and temperature. So this can be represented in the PV diagram from B to C. So this is called as adiabatic compression. What is this? Adiabatic compression. Have you heard about the adiabatic? In your second QC and chemistry and all, you heard about the adiabatic. So that means there is no exchange of heat from the system. So that's why it is called as what? Adiabatic compression. We are compressing the fuel. So this can be represented from D to C. Is it clear? Now, when the piston reaches the top dead center, when the piston reaches the top dead center, the spark plug ignites the spark. Okay, the spark plug is going to ignite the spark. The combustion of fuel takes place at constant volume. The combustion of fuel takes place at constant volume. This can be represented in PV diagram from C to D. Is it clear? So this is what the compression stroke from D to C and C to D. Is it clear? So this is the compression stroke. I will explain you once again. So during the compression stroke, the piston will be at the bottom dead center. Both inlet and exhaust valve will be closed. Now the piston is going to move from bottom dead center to top dead center. During the movement, it is going to compress the air fuel mixture present in the cylinder. When the piston reaches the before that, so that can be represented in PV diagram from B to C. So compression, so that is represented from B to C. So when the piston reaches the top dead center, the spark plug is going to ignite the spark. The combustion of fuel takes place at constant volume. So that's why see the line is straight. The volume is constant. The combustion is taking place. The pressure is increasing. Okay. So this can be represented from C to D. So this C to D represents the combustion of fuel. Is it clear? So up to D, the compression stroke takes. Now what happens? Next, what is the power stroke? So during the power stroke, where will the piston? Top dead center. Okay. So what is the difference of crank from this to this? 180 degree. Okay. 180 degree. So during the power stroke, what happens? See, both inlet and exhaust valve will be closed. Now, due to the combustion of fuel, the hot gases is going to expand. It is going to expand, and it is going to push the piston. It is going to push the piston from top dead center to bottom dead center. Forcibly it is going to push the piston. Okay, so the piston is going to move from top dead center to bottom dead center. So during this stroke, the power is being generated, right? During this stroke, the power is being generated. Hence, this is called as what? Power stroke. So this expansion is represented from D to E. So this is also adiabatic expansion. Okay, adiabatic expansion. Is it clear? Okay. Now, what is the position of piston? Ready? Now, the piston is at bottom dead center. Okay. Now, the piston is at bottom dead center. When the piston reaches the bottom dead center, okay, the exhaust valve is going to open. Inlet valve will be closed due to the spark. Okay. When the piston reaches the bottom dead center, the exhaust valve will be opened. So what happens? What may happen? Whatever the hot gases or waste gases which are present in the cylinder, so it will escape out to the atmosphere. Hot gases or waste gases will escape out to the atmosphere. This can be represented from, so D to E is over, E to D. So just due to the opening of this exhaust valve, hot gas is going to, some of the hot gas is going to escape. So this can be represented in E to D. Okay. So there will be drop in pressure due to the opening of the exhaust valve. There will be drop in pressure, and there is no change in the volume. Why? Because still the piston is at the bottom dead center only. There is no change. Okay. Now the piston is going to move from where? Bottom dead center to top dead center. So what happens? So whatever the waste gases was present in the cylinder, it will be pushed out to the atmosphere. Okay. So this can be represented in the PV diagram from B to A. Okay. So when the piston reaches the top dead center, the exhaust stroke completes. Okay. Once again, it will come to the point A. And so once again, the cycle is going to. So this is what the working of four-stroke petrol engine. Is it clear? I will explain you once again. Please listen carefully. Afterwards, I will be giving you 5 to 10 minutes of time to write yourself, to write and make the notes. Okay? So what is this? Four-stroke petrol engine. Why it is called as four-stroke? To complete one cycle, the piston has to go for reciprocate for 4 times. Okay? Hence it is called four-stroke. Why it is called as petrol? Because the fuel that we are using is a petrol. Hence the name is four-stroke petrol engine. Okay? So the first stroke is the section stroke. During the section stroke, the piston will be at the top dead center. Inlet valve will be opened and the exhaust valve will be closed. Okay? Now the piston is going to move from top dead center to bottom dead center. During the movement, the section will be created inside the cylinder. Due to this, the fresh air fuel mixture enters the cylinder. This can be represented in pressure and volume diagram from A to B. Okay, so thus ends what? Suction stroke. What is the next thing? Compression. During the compression stroke, the piston will be at the bottom dead center. Both inlet and exhaust valve will be closed. Now the piston is going to move from bottom dead center to top dead center. During the movement, it is going to compress the air fuel mixture present in the cylinder. This can be represented in the PV diagram from the part B to C. It is an adiabatic compression. So thus you can represent this in a sketch. B to C. So when the piston reaches the top dead center, the spark plug is going to ignite the spark. So the combustion of fuel takes place at constant volume. So this can be represented in the PV diagram from C to D. Hence, the petrol engine is also called as constant volume cycle engine. Why? Because the combustion of fuel takes place at the constant volume. Okay, so this ends the what? Compression stroke. What is the next thing? Power stroke. During the power stroke, both inlet and exhaust valve will be closed. So the hot gases is going to expand. It is going to expand and it is going to push the piston from top dead center to bottom dead center. So this can be represented in the PV diagram from D to E. Okay. So next is the exhaust stroke. When the piston just reaches the top dead center, bottom dead center, the exhaust valve is going to open. So due to this, some of the hot gases is going to escape. Some of the hot gases is going to escape. So this can be represented in the PV diagram from E to B. Okay. So now the piston is going to move from bottom dead center to top dead center. During the movement, it is going to push the waste gases out to the atmosphere. So this can be represented in the PV diagram from line B to A. So this is what the working of four-stroke petrol engine and the cycle. See, for each stroke, the crank has to rotate for 180 degree. 180 degree plus 180 degree, 360 plus 180 plus 180. That is totally 720 degree. That means to complete one cycle, the crank or crankshaft has to rotate how many rotations? So in the beginning, so when you are going to start the engine, see the compression stroke, sorry, suction stroke, compression stroke. So that will be powered with the help of batteries, right? So all of you are having the batteries, right, to start the engine, or we are going to kick it. Okay. So initial energy we are going to provide. Once the engine is going to start, so the energy will be stored in a flywheel. So remaining cycles, it is going to take the energy from the where actually the power is being generated in the power stroke due to the expansion of the arm axis. Is it clear? So this is what the working of power stroke. I hope you understood.